All right, today we're going to talk about permutations and combinations. We are starting chapter 11. Chapter 11 is a lot about probability. So we're going to talk a lot more about probability here. If you look in the back, there's a bunch of probability posters in the back there. But permutations and combinations, section 11.1. Permutations and combinations are one of the cooler things about math because it gets some weird math things out there that you don't think about. Okay, it starts talking about like ordering and placing and some different things that happens in your everyday life, but the different amount of possibilities out there are kind of crazy to think about. So a permutation. A permutation is a selection of items from a group in which the order is important. So permutations, the order is important. Can you make an example of something in life where order is important? Oh, we don't have any seniors. Huh? We don't have any seniors in here, but how many of you care about your class rank? Or some of you are like, whoo, really care about my class rank? Like, makes a big difference. The order is important there. Does it make a big difference if, like, you're number 6 as opposed to number 7 in our school? Is it number 6 in the top 10% then? 7 you're not? So it makes a big difference. All right, order is important. That would be a permutation. The order is important there. All right? In a permutation, AB is not the same as BA. Again, what that means is that the order is important. Another example is, a lot of times I use like a track meet. A lot of us do track. We talked about earlier hockey rankings. You know, it makes a big difference if you're number 4 or number 20 in the nation. Okay, it makes a big difference. The order is important. But again, the number of permutations and items taken are at a time as shown by the following formula. This is the permutation formula. Now, does anybody know what this exclamation point is? What does it mean to have an exclamation point? It doesn't just mean N, as you say it really loud and excited. It means something in math. Order down. So for instance here, if I were to have, let's say, 4, this is called factorial. It is factorial. 4 factorial means 4 times 3 times 2 times 1. So it orders all the way down to 1. Why would they not include 0? Does anybody know why? Because then it'd end up being 0 every time, which doesn't get us anything. Okay. Now, really, do you ever need to really include the 1, though? Probably not. Why? Because it's multiplied by itself, right? So, I mean, yes, you're going all the way down to 1. The only time you ever use the 1 if it's just 1 itself. Okay. So the question here states, how many ways can club members select a president, a vice president, a secretary, and a treasurer from a group of 10 members? Correct. Now, they kind of show you how to do it with permutations here with the formula. So again, what happens here is you have 10 over 10 minus 4 factorial. Now, that is one way to do it. I like to kind of just think logically about this and write it out. For instance, how many people could be chosen to be president? There's 10 people that could be chosen to be president. Well, after president's chosen, how many are left to be chosen as vice president? Well, after vice president's chosen, how many are left to be secretary? And then treasurer? 7. So it's nothing more than 10 times 9 times 8 times 7. In permutation, those end ones will always just cancel off or be left out. And then when you think about that here, there are 5,040 different ways for those 4 positions to be filled where order matters. Now, Matt, I believe you just got elected as student council president, right? Congratulations. And they did president, vice president, secretary, and treasurer, right? And you probably had more than 10 people up for nominations, right? So think about how many different ways there were. There are a lot of different ways, and this is kind of why this is cool math, is because nobody thinks about there's that many different ways out there. Okay? Let's try these here. So number 1, it says evaluate 8 factorial. And again, exclamation point means factorial. I can guarantee you will see something like that on an ACT or something.
This is going to be a calculator.
Huh?
This is going to be a calculator.
Okay. 8 factorial. Yes, you will need some calculator on some of these problems. No problem. All right, so 8 factorial. Well, what does 8 factorial mean? That means 8 times 7 times 6 times 5 times 4 times 3 times 2, times 1. And I multiply all of those out, I get 40,320. Craziness. Number 2, let's say we have 5 factorial. Well, 5 factorial means 5 times 4 times 3 times 2 times 1. I get 120. Nice job doing that mentally. Now, you can do a lot of this mentally just by grouping numbers together and arranging them, multiplying them differently. Number 3, 10 factorial. Well, what is 10 factorial then, sir? I believe you have it.
3,628,800.
So we have, let's say the 10 of us, you 9 and me included, and we were to stand in a line and see how many different ways we can arrange that line. Well, there would be over 3 million different ways we could stand in that line. Craziness. This is why it starts getting some weird, crazy math. Because again, once you just switch 2 people, that's a totally, completely different arrangement. And that's why there's so many different permutations. Now, number 4, 6 factorial over 3 factorial. Don't do them both and divide them. Because what does 6 factorial mean? 6 times 5 times 4 times 3 times 2 times 1. What does 3 factorial mean? 3 times 2, not half. It means 3 times 2 times 1. What do you know it cancels out? So when I have something like this, what am I really multiplying? 6 times 5 times 4. And to multiply those, I get 120. Again, so recognize, you don't have to do 6 factorial then divide it by 3 factorial. That gets too tough. Just write it in there and say, well, 6 times 5 times 4. I don't need 3, 2, and 1 because they're going to cancel out. Same thing on 5. What does 9 factorial mean? Well, that means 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 all over 4 times 3 times 2 times 1. 4s, 3s, 2s, 1s all cancel. I'm left with 9 times 8 times 7 times 6 times 5. And I get an answer that is what, sir? Mr. Lakin? 15,120. Nice job. And that'd be a problem like saying, oh, if I take the 9 of you and I choose the 5, ooh, nope, we have more than that, juniors, don't we? Dang. That's right. Take 9 of you and take the 5 hockey players. There you go. How many different ways could I arrange the 5 hockey players? 15,124. Yes, sir. Yes. Then 6, 15 factorial, 14 factorial. What's my answer, Miss Worth? Think about it.
I can't do that. I can't do that. I don't know, I'm under pressure like this.
Don't overthink the problem.
I just wrote 6, but I was sure I said it was 6. Is it just 1 or 15?
It's 15. Because 14 on down is going to cancel out, right? Yeah, don't overthink the problem. It's just going to be 15.
Yeah, we didn't expect you to do that.
Wow.
All right, number 7 here. Number 7. How many ways can the letters A through H be used to create 5-letter passwords if there are no repeated letters in a password? Well, let's think about it here. A, does the order of the letters matter in the password? Does the password, does it matter the way you put in your password?
Yeah.
Yeah, right? That order, order matters. So order matters, meaning it's a permutation. How many letters are there from A through H? There are 8 of them. Find the number of permutations of letters taken 5 at a time. Now again, there are no repeats. So how many letters can I choose for that first letter? How many can I choose for that second letter? And the third? And the fourth? And the fifth? Well, how many different ways are there then for me to choose that password? How many? 6,720 different ways for me to choose that password along. Okay? And this gets used into some crazy things with passwords. You know, does it add that many more when you can choose a capital or a lowercase letter. Well, yeah, then you really get a lot more, right? Well, what about if I can repeat letters? Well, then I add more passwords, those type of things. Okay. Now, what? And you can add numbers too. For instance, here, great story. We're all in Douglas County up here, right? Can anybody remember back when they were the one county on the license plate? Probably way past your time. Do you remember that? Like nowadays, license plates say what? Like, what are your license plates? 3 letters followed by 3 numbers, right? Way back when, they used to be one county, and it was like letter, letter, number, number, number. Okay? Well, adding an extra letter and going 3 letters and dealing away with the one county, they were able to include enough license plates that they will not run out again, basically. Just by choosing or adding one more letter to their license plate system. Just because all the different amount of orders that there are. It's crazy to think about that. Because most other counties still have this arrangement and they will never run out. But Douglas, Sarpy, and Lancaster County all have the special letter, 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 number, number, number. Craziness. But again, that's something that just happened here. Oh, it happened about 10 years ago, I think. Well, maybe more. Number 8. An editor has 4 different spaces to arrange articles in a magazine. He must choose from 6 articles. Well, how many can go in that first spot? Second spot. Third spot. Fourth spot.
2.
Oh, fakes you out. There's only 4 spots. You're just on the roll. So how many different arrangements are there for those articles? There are 360 different ways to place those 4 articles, or 6 articles in 4 spots. Nice job. All right. Those are permutations. Again, permutation, order matters. Next thing we're going to talk about is what's called a combination. Now, a combination is a selection of items from a group in which the order is not important. So a combination, the order does not matter. All right, in a combination, AB is the same as BA. You can make an example in life where order does not matter. So let's say you're choosing 10 people to be on a team. They're all chosen to be on the team. Doesn't matter in which way they're chosen at all. They're all still on the team. Okay? I always like to use the example of whenever you go to Subway to get something to eat. Now, some people are picky with how the order goes, this and that. But let's say you go to Subway and you want, a sandwich and you pick 5 toppings. Doesn't matter how those 5 toppings are put in your sandwich. They're all on the sandwich. You're eating them all the same way. It does not matter with which order they place them on your sandwich. Another example is in basketball we talked about earlier. 5 starters in the game of basketball. Does it matter in which way they come out to start the game? No, all 5 of them are still starting the game. Okay, that's an example. In hockey, there are 6 starters, right? So does it matter which way they come out? No, there are 6 starters out there still. Okay, order does not matter there. Now, recognize the formula here is a little bit tougher. There is a function on your calculator that you will probably want to use. There's no really clear-cut way as easy to do it as there was permutations. A little more tougher here. But combinations, there is the function NCR on your calculator. It should be right next to the factorial button in there. But the question says, how many ways can club members select a committee of 4 people from a group of 10 members? The order of committee members does not matter. Selecting Tom and Pat is the same as selecting Pat and Tom, which is true. The order does not matter. Okay. To find the number of combinations 10 items taken 4 at a time, use n equals 10 and 4 equals r. So they plugged into the formula here. On your calculator, you'd want to use 10, hit the NCR button, and then 4. Okay, you do the 10 NCR button, then 4, and then you should come out with what would be 210 different combinations. And again, why is this combinations? Because the order does not matter. Okay. So think about earlier. We had the same question earlier. What happens if we had 4 of them and the order did matter? Well, that answer there was like 40,000 different possibilities. Well, if order doesn't matter, it's just 210. So notice when order doesn't matter, your possibilities go down quite a bit. Kind of interesting. So let's try number 9 here. Evaluate 5, choosing 2. Okay, so your 5C2 or your 5 combinations 2, 5 choosing 2. What do you get when you go 5 choose 2, Miss Worth? It is 10. What about number 10? 7 choosing 6. And 7 chooses 6. You get what, Mr. Stefaniak? 7. And number 11, 9 choosing 4 gets me what, Mr. Melody? Number 11.
6.
What'd you say?
126.
126? Nice work. So let's look at number 12. A pollster has the names of 8 people available to answer her questions. She must select 3 of the people to interview. How many ways can she select the respondents? Does the order of the respondents matter? No, it does not. All 3 of them are interviewing. Does not matter. Find the number of combinations of 8 people taken at a time, or at 3 at a time. So that's like saying 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 5 times 4 times 3 times 2 times 1 times 3 times 2 times 1. Whew, good thing we have that combination function on our calculator, right? Because that looks nasty. You could do that. You know, your 5s cancel, your 4, 3, 2, 1. And then you just have to start cross-canceling there, like, 3 and 2, get rid of 6. Right? And what are you left with for an answer? 56. Hey, I still got that right there. And you recognize, you could write it out. It's just a little bit nastier when you write it out, right? Number 13. The track team has 6 runners in a race. The coach selects 2 runners to run in the first heat. And how many ways can the runners be selected? Write and evaluate the combination rule to solve. What is it, Miss Worth? 15 different combinations for those 2 runners. Nice job. All right, so try these 2 on your own. Take a couple seconds to try these 2. All right, so let's look at number 14 here. What is the answer, Mr. Melody?
6.
It is 56. Yeah, how many places are there for first place? Well, there's 8. And after first place is chosen, there are 7. So 8 times 7, that means there are 56 different possibilities. What about the state wrestling tournament? Well, now there's 32 wrestlers. How many different arrangements are there for the top 6? Well, first place is out of 32. Second place, first is out of 32. Second is out of then 31. Third is out of 30. Fourth is out of 29. Fifth place is out of 28. And sixth place is out of 27. When I multiply those up, how many different arrangements are there for that state wrestling tournament and the medal winners? It is. What do you got?
652,458,200.
There are over 650 million different possibilities just for 6 people to medal in a 32-person bracket. That is crazy.
How would you put that in, though?
Huh?
How would you put that in?
This one I would do like 32 times 31 times 30 times 29 times 28 times 27. I mean, you could do 32 factorial over what would be 26 factorial. 32 factorial would probably be an overload on your calculator, possibly. The 32 factorial? Because really it's like 32 factorial over 26 factorial. Is 32 factorial, is that an overload or not?
It's 2.6 with much numbers to the 35th.
Yeah. So that'd be 35th power?
Or times 10 to the 35th.
Yeah, so that's scientific notation times 10 to the 35th. That's rather large amount of numbers if you think about it, right? So, again, this is why this is kind of unique math, is because you wouldn't think about that. Most people don't think there's that many different possibilities out there. But when you start thinking every little move's a different one, there are. Try these 2. These are the combinations now. If there are 4 students, how many ways can I choose 3? If there are 14 students, how many ways can I choose 5? All right, Mr. Carlson, what did you get for 16?
4.
Yep, there are 4. And what about number 17? Mr. Heiss.
Um, 2002.
2002, nice job. Again, what's the difference between permutations and combinations? Well, permutation, order matters. Combinations, the order does not matter. Combinations, you're just choosing, order does not matter. Here's your assignment.